Honor to be here and to start the conference. The topic is future challenges for engine oils. We at Daimler see engine oil as an important design element. It's as important as a piston ring or camshaft. The quality of an engine oil has to be on the same technical level as a modern downsized engine. For an engine, the engine oil is nearly as important as the blood for a human body. So there's really a comparison. And one goal of my presentation today is to show you what future challenges we expect in future from our side. I will start my presentation with a short overview over our product portfolio and the structure of Mercedes-Benz oil specifications. I will continue, I will show you, I will inform you about the motivation and goals for new requirements, new specs, future challenges. I will show you some new tests, new requirements in detail. I will give you an overview over our actual and future Mercedes-Benz specifications, and I will finish with a short summary and outlook. For Mercedes, this year, or last year, was a very successful year. This is due to we have developed very fascinating products, new products in new and traditional markets. So new passenger cars, the new Mercedes front wheel architecture, you can see here. Of course, we develop products designed for our customers under the credo, best or nothing. Good lubricants are important not only for passenger cars, but also for heavy-duty trucks. On this chart, you can see an overview of the product portfolio of Daimler trucks. All the brands shown here are under the family of Daimler trucks. For common for passenger cars and heavy-duty is that we at Daimler see high-quality lubricants as important design element. It's important for all products. I will come now to the Mercedes specs, how they are structured. So the Mercedes oil specifications are based on ASEA oil test sequences, on API oil categories, and on SAE viscosity classifications. On top of that, we have developed our own in-house tests, lab tests, engine tests, new requirements, new tests coming from future challenges, reliability, fuel economy, biofuels, all these new requirements coming from internal, from the engine technology, from the requirements from exhaust after-treatment systems, from the service, from purchasing, sourcing. We have external influences coming from customers. Of course, a customer has to understand the specifications. We need the oils. They have to be produced by the oil and additive industry. They have to be tested at independent test labs. Some of independent test labs are here today. And we have to meet the legislation. We have to meet the emission standards. It's clear. The most important basic requirement for our Mercedes specs are the ASEA oil test sequences. Here on this table, you can see which ASEA sequence is the basic requirement for what Mercedes sheets. Just an example for passenger cars with DPF, diesel particulate filter, low ash. ASEA C3 and C4 are the minimum requirements for 22931, 51, and 52. But the ASEA sequences are not sufficient. We require more tests. We have more severe limits, and therefore Mercedes specifications are still necessary. Oops, sorry. If you look on the ASEA sequences, you will see that there are different requirements, and it is caused from different OEMs. So the different OEMs have different views, and this is also reflected in the ASEA oil test sequences. Unfortunately, the ASEA oil sequences does not warrant OEM approvals. The claims can be made on a self-certification basis, but ASEA has just started a registration system, which will be introduced in March this year. So the first draft was presented even last year. This is one step in the right direction. Another important basic requirements are the API oil categories. You know, there are the S categories for service, gasoline engines, and the C categories for commercial, for heavy-duty diesel trucks. We use, within Daimler, we use some API categories completely. So API CJ4 is the minimum requirement for MB 22831. Again, also here, API alone is not sufficient for MB approvals. We have additional tests, European tests. Yeah, that's API. For a customer, and the application of engineers, the SAE J300 viscosity classification is very important. Here on this table, it's well known to you. You can see the requirements SAE J300. On the right-hand side, you see a chart from Mercedes owner's manual. And what you can see is, I have highlighted the example, the SAE 10W. You can see requirements -25, -30 degrees Celsius. There are limits. But if you look on the application in the truck, this is from a truck, you can see for 10W, it's only allowed to go to -20 degrees Celsius. And that is because of, you have soot in the used oil, you have oxidation, you have a viscosity increase. So there is a difference between the fresh oil SAE J300 and the real application. And there was a development done by CEC, which helps us to be on the safe side. What are the motivations and goals for the new requirements and the new test developments? The most important goals are listed here. So fuel economy, CO2 reduction is the challenge, main challenge for the whole automobile industry. In 2021 in Europe, we have to meet 95 grams. Oil can play an important role. Of course, for our company especially, reliability and durability plays an important role. And we have to ensure good biofuel, bad fuel compatibility. Not all countries where we sell our cars have the best quality fuels. We have to meet the emission standards. Of course, the oil should have a low impact on the emission after treatment systems. We need a good corrosion protection, wear protection, sludge protection. These are classical goals. New is a low temperature pumping behavior, a good load carrying capacity, wear protection, and last but not least, good piston cleanliness. We have just started 1 year ago a new factory fill project. What you can see on this chart are the goals, the main goals and the priorities of the new factory fill project, which is called Challenge 2020. And you see on the top of this chart, fuel economy, the most important parameter. in this project. So the target is to introduce 0W22.6 and to get more than 1% fuel economy improvement versus the reference. The reference is a 0W30, HDHS 2.9. I have mentioned it already. The second important goal is to keep the reliability and durability. This new oil will be filled in brand new engines, direct injected, turbocharged with plasma sprayed coating, nanoslide coating, start-stop system. We want to keep the oil drain interval or even improve the oil drain intervals. And we want to have one oil for gasoline and diesel engine. That is because of particulate traps. We will see particulate traps not only in diesel engines but also in gasoline engines in future. So that the future is low ash. Of course, in some markets, we have to live with more biofuel content, bad fuel. And so the oil has to show a good oxidation stability and cleanliness. We will test all these oils, the candidates in M15, methanol, ethanol, E25, E85, natural gas, market fuels on the diesel side with B10, B15, and B20, not with all FAME, with more severe FAME like SME, soybean methyl ester. We have to meet the emission standards, so the oil should have a low impact on emission systems. And last but not least, for factor fill, price is always important, and availability. On this chart, I give you an overview over the test metrics for pre-screening for Challenge 2020. I will not go through all these tests. A lot of tests you have to do, or the oil industry has to do a lot of tests before we decide. We do a benchmark after these tests, and then we decide, based on the test results, we decide which two oil formulations we will use for further testing. Some of the listed tests I will explain in detail. The most important requirement, I mentioned it already, is fuel economy. So we developed four new fuel economy tests, and the old is still existing, the M111 fuel economy. 4 new fuel economy tests. Why that? We have seen that fuel economy is hardware dependent. It really depends which engine, which driver system you have in your engine. And so that's the reason. We used 4 cars. We run an NEDC cycle, the European driving cycle on the chassis dyno. And you can see the hardware dependence here. Oil 3 shows in the 4-cylinder very good. 4-cylinder car, diesel car, very good fuel economy. And the 6-cylinder, not as good. Another oil 4, shows a good behavior in the 6-cylinder, but not in the 4-cylinder. And you see that is due to different oil formulations, different base stocks, different friction modifier systems, and also different liner technology. So the 4-cylinder gasoline engines is a cast iron engine. The 6-cylinder CGI, direct injected gasoline engine, has an aluminum silicon liner, different driver system, different behavior on fuel economy oils. Fuel economy is not only important for passenger cars, but also for heavy-duty engines. A fleet owner, fuel cost plays an important role on the total cost of ownership for a fleet owner. And so we developed a new fuel economy test for heavy duties as well. This fuel economy test is based on the World Harmonized Transient Cycle. You can see a chart of the cycle. Here you can see the calculation, how we calculate the fuel economy benefit of the oil versus a reference. It's very, very important to have this test, and this test covers typical driving conditions in the European Union, but also in US, Japan, and Australia. In different markets, we have to be compatible with different fuels. And some of these fuels contain biofuels. And what we have seen is we get more viscosity increase and more oxidation. And therefore, we developed a new lab test which addresses this problem. Here you on this chart on the bottom, you can see the oxidation versus time. Without biofuel, the oil behaves very well. But in the case that if you add 5% biodiesel, there's completely other view. You see, oops, sorry, go back. You see a dramatic increase in the viscosity, in the oxidation, and that's not what we want to have. We run this test that I will not go through all the details. You can read it later on. But it runs 1 week at 160 degrees, 250 grams in this glassware, and it can be done at independent test labs listed here, APL and ISP. Biofuel has not only impact on viscosity increase and oxidation, also influences the corrosion behavior. We have looked what tests are available already in the market, and we used the high temperature corrosion bench test used in the API categories. We modified this test. We added, this is the standard high temperature corrosion bench test without fuel. You see the copper strip, lead and tin strip show low reaction only. But if you add biofuel, 10% FAME fatty acid methyl ester, you get a dramatic increase, really a dramatic increase in corrosion. And that's what we want to prevent. You can address this in the oil formulation with anti-corrosion additives. And that's what we want to have. So we have modified the existing test to be on the safe side. Biofuels, or we have to go to fuel economy oils, low viscosities, and so we are a bit worried about where. And so we developed the test. So the load carrying capacity test, Mercedes Schwingreibverschleiß test. This is a test where we use our original piston ring, now original part of a liner. You can see segments, the ring segment, and we bring that in an oil bath, lubricant bath, heat it up to 130 degrees Celsius and do friction tests. So it is a 3 hours, 20 hertz stroke, and we can check if we get washboard wear or not. Only oils without washboard wear will be approved. Last but not least, we have more severe limits in already existing well-known tests used in ASEA, but also in our specs. We have just introduced more severe limits for cam wear, minus 10 microns, more severe limits for engine sludge. Why that? The 646 represents not the latest engine generation. And the future engine generations, downsized engines, have even more power, more torque, and will run with steel pistons. This engine still has aluminum pistons. And so we have to address this in the existing test with more severe limits. Same for heavy duty. So the current engine test we use in the ASEA, but also in the Mercedes sequences, is the OM501. It looks mainly on piston cleanliness, but in the Mercedes specs also for other test parameters. We've just introduced new limits, more severe limits for piston cleanliness, 2 piston merits more for all categories. Reason is the successor engine, the heavy-duty engine platform, worldwide global engine platform, runs with steel pistons. Steel pistons become hotter, so we get more deposits, and we have to address this with more severe limits. And we have we see more biodiesel in the markets. When we started this test development, B0 was in the market. B0, no biodiesel. But these tests run with B5, with a B5. Today in Europe with B7, in some markets even B20. In France you can get B30. And we have to address this with more severe limits. Last requirement is the oil elastomer compatibility. Some of you are already aware that the old reference materials contain toxic components. So we have to replace the materials completely. All seal materials have to be replaced by new ones. And this is a good chance to switch all our internal seal tests to the new ASEA materials as well. So we have to wait until the CEC task force group will decide on new reference materials. And our expectation is that the new materials will be more sensitive to the oil than the old ones. But we will take over. Now I want to give all these tests I showed you before are part of the Mercedes oil specifications. Here in this table you can see an overview. So we have splitted our specs in heavy-duty engines, engine oils, and passenger car engine oils. High ash, low ash, high ash, low ash. We have 3 quality levels. Some expect more. In our understanding, it's sufficient. It's even too much that the customer can't really understand it. So we have standard quality, medium quality, top quality. Same logic for heavy and light duty. 2281. 1 is the standard quality, 30,000 kilometers, 60,000 kilometers, 2285, 100,000 plus. Oops, sorry, I have to go back. 135. Same logic for low ash. We start with the medium quality 3151. Same logic for passenger cars 229135. We've just introduced a new spec for the corporation engines. We have a cooperation with Renault. It's well known. We use the small engines from the corporation. And the same for low ash 22931 and 51 as low ash specs. Here on the left-hand side, you can see the overview of a chart. You cannot read it, but you can download it on the website. All approvals can be done, have to be done online in the internet under this link. And all approved products are listed in the internet as well. You can have access 24 hours, independent where you are, worldwide available in the internet under this link. And we are now working on an app for iPhones and for Android smartphones. And a customer can check in future in the supermarket or the gas station if the oil is approved or not. It takes your smartphone, we start now with a QR code on the drums, and a customer can easily check if a product is approved. If it's approved, you get this signal, yes or no. So very simple, and we hope that the customer then has a better chance to find a good oil. So now outlook, future. I already mentioned Challenge 2020. Here a short summary what we expect in the Challenge 2020 project. So we started this project with the main goal, fuel economy. You see the 4 fuel economy tests, NEDC tests, and we expect more than 2%, up to 3% fuel economy benefit with the new 0W22.6. We have more severe limits for the low temperature pumping. We have limits for phosphorus, minimum for TBN. And we'll introduce this new factory fill in 2015 for the upcoming engine generation. And as I said, for diesel and gasoline as well. So I come to the summary. Our Mercedes-Benz specifications are based on 3 quality levels. The specs are based on the ASEA sequences, but also API and SAE viscosity classes. Future challenges lead to new test requirements, new tests, new limits because of these reasons. And this, at the end, this keeps us busy. New requirements, new engine tests, and new or more severe limits will lead to new Mercedes specifications for future engines. Thank you very much for your attention.
Michael, thank you.
Yasin from Total Oil, Pakistan. Very good overview for the future. My question is that if the 20W, 0W20 is going to be the future direction for the SE viscosity, has this have any consideration throughout the world, the tropical countries like Middle East and all that area where the temperature is very high? So generally the tendency in the Middle East is not to go to that lower side, irrespective of the OEM approvals. So my question is that have we considered all this when we have been designing the new SAE specification, which is 0W20? This is question one. The question two is the biofuel will be available in that part of the world where you have very, very large share of the market. So when you were designing all these specifications, I know that fuel economy is a driving factor for that. In spite of that, in the Middle East, the fuel economy has no relevance. And you have excellent market share in that part of the world.
Thank you very much for the questions. To your first question, it's clear that we will not remove the good old specifications, high ash, where the market fuels are not as good as in other places. And of course, fuel economy oils should not be used in older engines. So the engine design has to be adapted for the low viscosity. So the old engines still can live with the old oils, high viscosity oils, but the new engines are designed for these low viscosities and can also use these new categories. And there will be, by the way, a new category in the ASEA sequences, which is nearly very similar to what I have presented to you today for Challenge 2020. It's ASEA C5, and there are more members within ASEA wants to use low viscosity oils to improve the fuel economy. Fuel economy will be the major topic in the future worldwide. So 95 grams in 2021. So every small portion, independent where it comes from, and it's important. I can remember, you have to pay a lot of money if you're not meeting the limit. It's 95 grams. And so this is very important. Biofuels, of course, it depends on the market where you want to sell your cars or trucks. What fuels are available in the market. And dependent from the fuel quality, we have to decide what oils can be used in this market. Not all markets, low ash is necessary, because if the emission standard and the fuel quality does not allow DPF, we don't need low ash oils. So it's clear. It's really, you have to look what market you have, what is the situation in the market, and then to decide what oils have to be used. Hope this answers the two questions.
My name is Yasushi Naito from Evonik, Japan. My question is regarding turbocharger deposit. And US industry uses Teosto 33 for evaluation for turbocharger deposit for passenger car. And how do you think the turbocharger deposit for Daimler Chrysler, a passenger car engine?
Yeah. So turbocharger deposits is an ongoing topic. We had this with the introduction of biofuels, or even earlier. We have seen turbocharger deposits. So we have addressed this in tests, engine tests. So nearly all engine tests I have showed you today, the 646, but also the 501. The turbocharger rating is part of the test. We have also the MTU deposit test to look for the turbocharger deposits, but that is still a topic, and we have to discuss if we need a separate turbocharger deposit test within the ICEA sequences. So this is, I think there's a need. Some OEMs need a test, and yeah, there are proposals available, and we have to check if this test proposal can be used within ICEA or correlate with the findings from the OEMs. On the heavy-duty side, turbocharger deposit was always part of the heavy-duty engine tests. The 441LA turbocharger boost pressure loss was the parameter we tested, we checked, and the 501 is the same. The turbocharger deposit is a topic. Yeah. Keeps us busy.
Okay, thank you.
Thank you very much, Michael. For the sake of time, we're gonna move on. Please feel free to interact with Michael if you have any other question. Michael, I believe we have a small token of our appreciation here with a plaque. So I'm gonna call Gary and Vicky on stage, basically, and thank you so much for your presentation.
Thank you, Johnny.
And I repeat, as a small token of our appreciation, please accept that plaque from us.
Michael, in appreciation for you coming out to Asia and giving the keynote this morning, we'd like to offer you this. It says, presented to Michael Schenk, Manager, Automotive Lubricants, Daimler AG, for his keynote address entitled Mercedes-Benz Oil Specifications, Future Challenges of Engine Oils. I think one thing you didn't mention was China, I think now is your #1 market for the S-Class. And by 2015, I think China will be your #1 market in the world. So we appreciate you recognizing the importance of this region and coming out here and giving us the keynote today. So thank you very much.
Okay, thank you very much.